This is a screenshot from that Select Pro software. And it will highlight in green possible selections. Normally what it'll do, it'll highlight one below and one above to calculate the CV. And then down at the bottom, it will tell you what the effective pressure drop is. So we are looking at a pressure drop of 4 in the example. It's showing that the effective pressure drop is 4.4. Well, if in your spec you call for a maximum of 4 PSI, that's not going to fit your spec. A lot of times the spec reads a maximum of 5, so if you're anywhere in that 3 to 5 PSI range, you're good. So this is just the calculation. They're using a valve with a CV of 19. So the calculation to see what the pressure drop is, if you're doing the calculation rather than the Select Pro tool, take your GPM divided by the CV, and then you square it. So 2.1 squared is that 4.4 we saw from the Select Pro tool. So that shows to be within the 3 to 5 PSI guideline. Like I said, it will depend on your spec. You know, if that's going to meet it. If it doesn't say anything in the spec, then that would be a good valve to use. So now if we're using that 24 CV, that comes up with a pressure drop of 2.9 PSI. That's outside of the 3 to 5. So if you cannot use this valve, you can use any valve you want, because we would not recommend using this valve at that pressure drop. This is just a similar exercise. GPM is 20, CV is 10, delta P is going to be 4. It's cut in half. So you can see how that plays out. So piping geometry needs to be considered. For example, if you've got a full ported ball valve, it need to be considered. The CCVs, it's not a big deal. When you use flange valves, then it can come into play sometimes as well. So when it does come into play, a reduction to pipe size can mean a reduction in your CV. And this is a chart right out of the PGPLs you have. But we can see here that a B220 with a CV rating of 24 that we were looking at earlier, that's a 3/4 inch valve. So at 3/4 inch, it's going to have that CV of 24. If we install it in a 1 inch valve, CV drops down to 19. So you can see as the difference in size of the valve and size of the pipe gets greater, the CV goes down on valves where this is effective, like a full ported ball valve. So this is just an example of using that chart. You've got an 1.25 inch valve, 19 CV, but it's being installed in a 2.5 inch pipe. Adjusted CV goes down to 7.89. Similar scenario here, 3 inch and a 6 inch line. Drop from 70 down to 68. And then, similar scenario, 1/2 inch valve, 1 inch line, CV of 10, CV goes down to 6.3. Here's another screenshot of the Select Pro tool. At the top, you can decide what type of valve you want to use, and again, if you don't select, you're going to get a lot more options there. Yes?
Down on that last slide, I don't know if it's just a misprint in our books, but the last page for your pipe 6 inch, it's got 46, and pipe 1 inch has 340 in our workbook.
No, nothing misprint.
Okay.
Yeah, that ended up coming down from up here.
Okay.
Yeah.
sized pipe.
That would be some good sized pipe, that's for sure.
Yeah, because the one is valve.
It's actually the workbook.
It's in the workbook.
Page 55.
About that, I turned right to it. So if you want to write down page 55 in the workbook. See, pipe size on 46. So yeah, like I said, this is the screenshot of the Select Pro tool, and you filter down, put in all the information that you can, then you get selections down here. Like I said, they highlight in green some recommended selections, and then down at the bottom here, this one, they have these in green. I don't know that I would recommend that. The pressure drop through those is 7.3. It's kind of high. You actually get good modulating control out of that, but you get to the point where you might start having noise issues once you start having those higher pressure drops. And again, similar to the damper actuator, you can add to the schedule and start building up a valve schedule here. So that was for pressure-dependent valves. Pressure independent, so much easier because you just have to know the GPM. So you need to know pressure pushing water through the valve in order to determine the flow of the valve. That would be on a pressure dependent valve. Whereas with a pressure independent valve, it's rated in gallons per minute. You know your GPM. Like I said, we don't have every single GPM available, so you can just go up. For example, if your coil was supposed to be 8.25 GPM, you could go to 8.5 GPM, something of that nature. So because we don't care about pressure, and we don't have to worry about a piping geometry factor here, because it's like the CCD, it does have a characterizing disc, so that's not an issue. Then we're not going to worry about that, the pressure drop at the bottom of that CD formula. Like I said, with pressure independent valves, GPM is used for sizing. The EPIV, you can see 2.5 inch, top GPM is 127, down to our 6 inch where the top GPM is 730. So it's all based on the flow requirements you have. And it's the same scenario with the energy valve. Same valve as the EPIV, just with a couple extra features, so the sizing is the same. CCD orientation and assembly. This is good if you need to assemble, need to replace an actuator in the field, something of that nature. So, the scenario that we're looking at here, the valve's installed, should be operating as normally closed, fail closed. However, the valve is open or it doesn't close all the way. So what do we have here? We have LF24-SR, B219 valve body, WLF linkage. Here at Jackson, they can build up a valve for you like this. They have all the components and they can just build it up. They also have some valve assembly already built up. So if we want to replace the motor on the valve, say the motor had a problem, well, then what we can do, we can get a new LF24-SR, and maybe part of the problem was the normal and fail position were incorrect. So in here it says, if you were to open this or order this kit,